Okay, now that we know what radius of convergence is, we are going to look at interval of convergence. So this is where you will have to solve the inequality and also check the endpoints. Remember, on some endpoints it may converge or it may diverge. So again, we're going to start the exact same way. Either it's got to be a geometric or you can use the ratio test. So if I look at this example here, I notice that it is not a geometric, so I'm going to set up my ratio test. Multiply by the reciprocal. Okay, let's simplify this a little bit. I'm left with an x, and n on the top, n plus 1. When I take the limit of n over n plus 1 is 1, ratio of the lead coefficients, so this is my limit, and the ratio test says it only converges if this is less than 1. So this is the inequality that I've solved. Now if I'd ask you what the radius of convergence is, you would say the radius of convergence is 1 and you're done. But because I'm asking you for the interval, you must also check what happens at the endpoints. So at x equals 1. So all I'm doing is taking that x equals 1 and plugging it into the original series for x. If I do that, I end up with this. But 1 to the n is always 1, so I can really rewrite this as this, which is a p series that diverges. I'm going to do the same thing with negative 1. So I'm going to take that negative 1 for x, plug it back into the original, and end up with this series. I notice that is an alternating series, so let's check. Is the limit of the general term equal to 0? Yes. Is the n plus first term less than the n term? Yes. So at x equals negative 1, it converges by the alternating series test. So your final answer that asks you for the interval of convergence should be, I want to include negative 1 but not include 1. So this should be your interval of convergence. You can either write it with interval or you can do inequalities. Doesn't matter. Okay, let's try one last one. Find the interval of convergence of this series. Again, I notice it is not a geometric, so I'm going to go ahead and do the ratio test. N plus 1, n plus 1 squared times n squared over x minus 1 to the n. Again, I'm going to simplify things a little bit. I notice this x minus 1 to the nth will drop out, cancel. So really, I'm left with an x minus 1 to the first. I have an n squared, n plus 1 squared. Now take the limit. N squared, n squared. Ratio of lead coefficients is 1. This is my inequality that I need to solve. Ratio test says it only converges if it's less than 1. Let's solve this inequality. So this is my inequality. Again, if it only asked you for the radius of convergence, you would tell me that the radius of convergence is 1 and you can stop, but this asks for the interval of convergence. So I must check the endpoints. So my two endpoints are x equals 0. So I'm going to take x equals 0 and plug it in for x into the original series. If I do that, this series becomes this. I notice it's an alternating series, so let's check the two conditions. Is it true that the limit of the general term is equal to 0? Yes. Is it true that the n plus first term is less than the nth term? Yes. So at 0, I can say it converges by the alternating series test. Let's check the other endpoint, which is x equals 2. Same thing. I'm going to take x equals 2, plug it in for x into the original. If I do that, I end up with 2 minus 1 to the nth, which is 1 to the nth, which is always 1. So notice this is just a p series that converges. So this particular series, when I do the endpoint analysis, both endpoints converge. So your interval of convergence should include both of those endpoints. So the interval of convergence is from 0 to 2.